Hey guys, today we're going to talk about something brand new, and that is called logarithms. So logarithms are the method that you're going to use for solving an equation whenever you have your variable or your x in an exponent like that. And if you're curious, logarithm, it's written right there so you can see how to spell it. So basically, as of right now, you don't have a way to solve for x when it's in an exponent. You would just have to graph it and then find an intersection. But I want you guys to be able to solve those by hand as well. And to do that, you have to use a logarithm. So what I would do is I would write down both of these just like ways of changing back and forth between an exponential and a logarithm. What happens is a logarithm is actually the inverse of an exponential equation, and since it's the inverse, it can get that variable down from the exponent for you, and it uses this method of doing that. So if you're starting with a number raised to a variable and an exponent and it equals another number, then what you would do is you need to change it into this form here, where you have log, and then you're going to put your base a little bit lower than the actual log thing. So in this case, our base is 4. And then you're actually going to put the number on the other side. So it'd be log base 4 of 8 equals whatever was in the exponent. So it's going to equal x. So then you have this log base 4 of 8. So that is actually going to calculate out and be a number that you can actually evaluate. So the way that you do that on a TI-84 calculator is you're going to hit math and then press up, up. And that's going to give you a log base button. Some of the older calculators don't have this, so if you have one of those calculators, just watch out for that. But then you're just going to type in the 4 in the lower spot and the 8 in the parentheses and press enter, and it'll calculate that for you. So that tells us that x equals 1.5. So if I went back and I wanted to see it back the other way, what that's saying is that 4 to the 1.5 power equals 8. So I'm just going to type that in to make sure that what we did was correct. So 4 to the 1.5 power, it just equals out to be 8. So we know that this is correct. So the biggest thing that you need to do is write down this information at the bottom so that you can change back and forth between exponential forms, which are these two on the left-hand side, and logarithmic form, which is this on the right-hand side. And the reason why there's two different ways of doing it here is I just wrote it out in words on the top in case you are better at following it if it's written out in words, and I wrote it with different letters on the bottom in case that method is easier for you. So if you were doing it that way, then in the problem that we did, you could have said A equals 4, B equals X, and C equals 8, and then you could have put it into this form of log with A being 4, B being, or C, excuse me, being 8, and B being X. So if you work better with letters, then you can write down the second form, but if you work better with just words, then you can write down the first line there. Okay, so then this is going to be a few more actual notes, and then we're going to get into some examples. On all of the slides, I'm going to keep this part here so that you can see how to go back and forth between exponential and logarithmic form. So the three examples that we have here are all already in logarithmic form. So that's these on the right-hand side. So there's three different ways that you'll see logarithms written. There's the first method where there's no base given. And if there's no base given, that means that there's automatically an implied base of 10. And then in the second form, this says log base 3 of x, so that's where it just gives you the base. And so in that case, the base is 3. And then the last form, this actually says ln. It's not in, it's ln. That's how I'll be writing it. And that is called the natural logarithm. And I'll be referring to that as natural log. And the natural log has a base of e. So remember in your calculator to get e, you would hit second divide. So the natural logarithm, the base in that is going to be that e button, or that e number. It's like 2.7 something. So if you wanted to actually solve these out, then in the first situation, it has an implied base of 10. So if I'm going from this form to this form, then the first thing I need is my base, which it says is 10. The next thing I need is my exponent, which is the number that's on the other side, which is 2. And then I just need the number on the inside, which in this case is x. And so then that gives us x equals 10 squared, so x is going to equal 100. In my second example here, I'm going to need my base first, which my base in this one is 3. Then I need the number on the other side as my exponent, and so that's going to be 2, and it's going to equal x. So in this one, x is 9. And in my last one, it's the natural log, so that means my base is e. So that's the first thing I need is that e, and then I need the number on the other side, which is 2, and it's going to be equal to x. So in that one, I'm actually going to have to calculate out what e squared is. So I'm going to come to my calculator. To get e, I hit second divide, and then I just need to square that. And that's going to equal 7.389. So that's how you would solve those specific examples, but the main thing that I need you to take note of is if it just says log and it doesn't tell you what the base is, then it automatically has an implied base of 10. The second scenario, if it has that little number down there, then that gives you the base. It's telling you what the base is. And the third scenario is that natural log where it has a base of e. Okay, so now I just want to go through and do a few different examples. So the first one, if you look at it, it's currently in exponential form. There's no log, so we're going to need to go from exponential form to logarithmic form. So the first thing you need is log, and then you need to see what your base is, and the base of the exponent is 3. Then you need whatever number is on the other side of the equal sign, which is 27. And then it's going to be equal to your exponent, which is x. So now we have log base 3 of 27. And I want to show you guys another way that you can do this in case you don't have a calculator at home. I actually found this online calculator that you can use instead. So you would just type in whatever base you have. So we have the base of 3, and then it's of 27. And you'll just hit calculate. And it gives you that the answer is 3. So the base 3 logarithm of 27 is 3. So that means that x equals 3. So then in my other problem, we have log base 4 of x equals 2. So this time we have the log form, and we need to go back to the exponential form. So the first thing that we need is the base, and the base in this problem is that 4. And then the next thing we need is the exponent, and the exponent is whatever is on the other side of the equal sign. So, So the exponent is going to be that 2, and it's going to equal whatever the number inside the log is, which in this case is x. So that gives us x equals 4 squared, and 4 squared is 16. And here are two more examples. So the first one, it starts with a logarithm and you have to change it from the log form to the exponential form. So the first number that you need is that base. And so the base in this case is 6. And then you need to raise the base to the number on the other side, which is 3. And it's going to equal the number on the inside of the logarithm, which is 2x. So then we need 6 to the third power, which gives us 216 is equal to 2x. And then in this one, we have to do one more step where we have to go ahead and divide by 2 on both sides. And you'll get x equals 216 divided by 2, which is 108. On my next example over here, we have 3e to the x equals 9. So I want to go ahead, well, first I want to go ahead and say we're going from exponential form to logarithmic form. So we know we're going to be using a logarithm because that variable, that x, is in an exponent. And then I want to say, before changing it into logarithmic form, get the base and the exponent by itself. So get base and exponent alone before changing the form. And you guys should make a note of that as well. So what I mean by that is that in this scenario, our base is going to be that e. So since the e is the base, we need to get the e to the x alone before trying to solve. So we need to divide by 3 before doing anything else. We need to do that on both sides. So then we would have e to the x equals 9 divided by 3, which is 3. And now we can rewrite it as a logarithm. So you would have log base e of 3 equals x. And then I want to point out that we have log base e. So anytime that you have log base e, that is actually going to be the natural log. So you can change that to ln of 3 equals x. And then if you look on your calculator, then there's actually an ln button right there. So you can just type in ln 3. And you'll get 1.099 if you round it. So that would be your answer. And then since I was just talking about the ln button, there is a just plain log button that's right there on the calculator above the ln button. And that's going to be that regular logarithm that has that base of 10. So if you need to use a logarithm with the base 10, you can just use that button. Otherwise, you're going to need to do that math up, and get the log base in there. And then since I have the log base in there, I will go ahead and show you as well that if you didn't notice that the base was e on that last equation, and you just went ahead and typed in log base e of 3 instead of doing the natural log, then you will still get the same answer. But you just need to know that ln, or natural log, it does have that base of e, so you could just use natural log. So then we just have 2 more examples and then we'll be done. So the first example is 2 times log of x plus 1 equals 5. So in this one, just like in the last one where you had to get the base and the exponent by itself, you're going to want to get the logarithm by itself first before changing. So that means I need to divide by that 2 on both sides. So then I'm going to have log of x plus 1 equals 5 divided by 2 is going to be 2.5. And so then this is just that case where you just have log. It doesn't tell you what the base is. and we need to change it back into this form where we have base to an exponent. So if it just gives you log and it doesn't tell you what the base is, that means that you should automatically know the base is 10. And then we're going to raise that to the exponent, which is the number that's found on that other side. So that's going to be the 2.5. And that's going to equal x plus 1. So first we need 10 to the 2.5. And that's going to give us 316.23. And then it equals x plus 1. And then you just need to subtract 1 on both sides, and you'll get 315.23 is equal to x. And that is going to be your answer. So then we just have one more. We have 12 to the y minus 2 equals 20. So that's currently in our exponential form, and we need to rewrite it as a logarithm so that we can solve for that y that's in the exponent. So the first thing I'm going to write is log. So I'm going to have log, and then I need my base, which is 12, of the number on the other side, which is 20, equals y minus 2. So then I need to evaluate log base 12 of 20. So I'm going to use my calculator to do that and press math, up, log base 12 of 20. And that gives us 1.206. I'm just going to say 1.21 equals y minus 2. And then to get the y by itself, you just need to add 2 to both sides. So then you're going to get 3.21 equals y. And that is all. So just some basic overview notes. Make sure that you have this written down so that you know how to go back and forth between the two forms. Make sure that you know the 3 types of logarithms and you know what the base is. And then another thing, if you want to write it down, to get log base in your calculator, you're gonna hit math up if you have a TI-84. If that isn't working for you, then I did post that logarithm calculator on Google Classroom and in the weekly assignment calendar, so you can use that instead. So that's about all. Just let me know if you have any other questions.